So this is the final video covering activity 3.7. Here you're going to use logs to solve equations. Okay, so let's go right to the practice problems. We're asked to solve each equation by estimating the solution, solving graphically, and using logarithms. Okay, so let's start with estimation. Okay, I want to move this to a new page. So if I had to estimate, well, we're trying to figure out what value of x would result in 150. So if I said, okay, we have, if I had 10 raised to the 1, I get 10. So you know that 1 is too small because we need 150. And if I had 10 to the second, we get 100. That's still too small because I need 150. So about 10 to the 3. That's 1,000. All right, that's too big. So the value of x that makes this true is somewhere between 2 and 3. So for my answer, I'm going to say the value of x is some number between 2 and 3, probably closer to 2. Why is it closer to 2? Well, when I think of 100 and 1,000, 150 is definitely closer to 100 as opposed to 1,000. So the value of x that makes this true will be closer to 2. So let me type up my solution. So thinking about my estimate, I'd say x is somewhere between 2 and 3, and x will be closer to 2. Okay, so just think about it. We know our answer is going to be around 2 point something. Now we're going to solve graphically. All right, so if we take out our graphing calculator, if we graph both sides of this equation, all right, so the right side of the equation is 10 raised to the x, and I put that in y2. You can put it, it doesn't matter if I put it in y1 or y2. And then I'll graph y1 is 150. All right, so again, if you wrote 150 where y2 is, that's fine, and 10 to the x where y1 is, that's fine. For our window, I'm going to say 0 to 10 and 0 to, well, I know I'm going to have a straight line at 150, so my y max has to be bigger than 150, okay? Because if you think about it, y1 is going to be a straight line at 150. I press graph. Okay, here's my straight line at 150. We're looking for this intersection, so I press second, trace. Oops, let's try that again. Second, trace, number 5 for intersection. And then I'll press enter, enter, enter. And it says the intersection is happening at 2.176. So let's just call this 2.2. Does that make sense? Well, remember, our estimate said the answer x is going to be somewhere between 2 and 3, closer to 2. When we graph it, we get 2.17, so that makes sense. So on your test, if you solve by graphing, I'm going to ask you to actually sketch a copy of this graph on your paper. Okay? Now, by using logarithms. Okay, so we're going to say to solve the same problem using logarithms. So I can rewrite this equation using properties of logs, right? If my base is 10, couldn't I write log base 10 and the 150 comes inside and the x is on the outside? And really what you would enter in your calculator, right? Because it's assumed if there's a 10 down there, I don't have to write anything. I can just actually enter this, log 150 equals x. So let's take out our calculator, and I'll press second and quit to get out of here. I press the log key and 150, close my parentheses, and look at that, 2.17, right? Which is what we had here, right? X will be closer to 2. When we graphed it and we found the intersection, we had 2.17, right? So that's us solving this using logs. Here is the work for solving via estimate, and the graphical solution was finding the intersection between the left and the right side of the equal sign. Okay, so let's try another one. Let's try number 40. All right, so for number 40, again, if I'm going to solve by estimating, right, so we'll do part A will be estimate. Remember, 10 to the 1 is 10. 10 to the 2 is 100, right? That's still too small. We need 725. 10 cubed is 1,000. So that's our winner, right? So we know the value of x is going to be between 2 and 3, all right? Because 725 is between 100 and 1,000, okay? So let's type our answer. All right, so our estimate will be x is some number between 2 and 3, closer to 3. Now this time we said closer to 3 because 725 is closer to 1,000 than 100. So our answer will be closer to the 3. All right, so that's us solving using estimates. If we wanted to solve by graphing, go to y equals, and I'll clear this out. This time I'm going to put 10 to the x and y1. If you left 10 to the x and y2, that's fine as well. And then the right side of the equation was 725, right? So we had 10 to the x, I put as y1, 725 is y2. Again, you can switch the order, it doesn't matter. All right, but my window, we're going to have a straight line at 725. So when I press window, my y max has to be bigger than 725. I'll use 800. If you use 750, that's fine. Just any number bigger than 725. Okay, this is first line. Second line's coming. And remember, we know the answer. The answer is going to be somewhere between 2 and 3, closer to 3. So I press second trace, number 5, enter 3 times, and my intersection is at 2.86. Does that make sense? Well, we said the answer would be between 2 and 3, closer to 3. And this 2.86 is definitely between 2 and 3, closer to 3. Okay? And again, on a test or a quiz, I'd want you to actually sketch the graph, label the intersection, and write your final answer, x equals 2.86. Last one is, our last way would be by using logs, okay? So we'll call that part C, right? So part B was the graphing, part A was estimate. So again, the base of my exponent is the 10. Oops. Right, the base of my exponent is the 10. So I have log base 10 of 725 equals x. And really, for your calculator, you would really just enter log 725 equals x. So I take out my trusty calculator, I press second mode to quit, and I enter log 725, press enter, 2.86. And that's what we, remember, that's the same answer we had when we graphed it and found the intersection, right? And it still makes sense, right? X is between 2 and 3, closer to 3, 2.86 qualifies. All right, that's it. Thanks for watching.